Okay, in this video lecture, we're looking at muscles, and we want to get a good idea of these three learning objectives. Number one, describe the basic way that muscles move bones. At this point, even not having really started muscles, you all should be comfortable with the idea that muscles move bones. If I said to any of you, put your hand on your biceps or put your hand on your deltoid, and let that muscle do its function. Whatever that function is, then you all would end up moving your shoulder. You would move the brachium, you would move the humerus, because that muscle attaches to the humerus and it moves it around in different ways. And so you already have a sense that muscles themselves move bones. So we want to understand fundamentally how that works. And in future videos and future lectures, we'll explore a little bit more of the details behind it. But for today, for this lecture, the basic way, fundamental description of how these things work. Next, we need to describe the three planes of movements, because if I say to you to move your deltoid or to contract your deltoid, your shoulder moves, but we need to be able to describe that movement. If you were to give directions to somebody out there on the street to say, hey, how do I walk to the nearest Starbucks, then you wouldn't just say, move, walk. You would say, well, walk this many blocks that way, and then take a turn and walk 2 blocks to the left or west or north, or however you want to describe it. But you would have to describe these movements. And so in learning objectives 2 and 3, we need to describe the 3 planes of movements, and then what those, and these are actually the 3 planes: sagittal plane, coronal plane, transverse plane. And then describe the movements that exist within the sagittal plane, within the coronal plane, and within the transverse plane. You should have seen that other YouTube video, and hopefully you've watched that one first before you're watching this video. So if you've not watched that yet, then shut down this video, go watch that YouTube video that I posted, understand those planes of movements, and then come back and start with this video. So these are the 3 planes of movements, and these are the movements. We need to get to the movements within those 3 planes. Okay, so here are the movements. So let's look at it. Here are the 3 planes: the sagittal plane, the coronal plane, transverse plane, and then these so-called special movements. And these are the major joints of the upper extremity, because the intention is we're going to start with the upper extremity and then go into the other regions. So the major joints of the upper extremity are the shoulder, the elbow, the wrist, and the fingers. The movements of the shoulder within the sagittal plane are flexion and extension. The movements of the elbow within the sagittal plane are flexion extension. Same with the wrist and same with the fingers. So flexion extension are the sagittal plane movements. And again, that YouTube video does a really nice job of describing and showing and illustrating what flexion extension are, what those movements look like. The movements in the coronal plane are abduction and adduction. And again, refer to that video to look at what abduction and adduction look like. In the shoulder, there's no abduction adduction in the elbow. You just can't do that. You'd have to tear ligaments and break bones in order to get that movement to occur. In the wrist, we see radial deviation, ulnar deviation, and again, it's in that YouTube video. And then fingers, there are abduction and adduction. In terms of transverse plane, the shoulder has medial and lateral or internal external rotation, and the elbow, wrist, and fingers really don't have that movement. Special movements then are circumduction, which was also demonstrated in that video, as well as supination and pronation of the elbow. So supination and pronation of the elbow are considered special movements. So what you should do at this point is you really should pause the video and then stand up and take your shoulder through these movements: flexion, extension, calling them out as you do them, then take it through abduction, adduction, describing them as coronal plane movements, take it to internal, external rotation, etc. And do the same thing with the other major joints. You need to be very, very comfortable with this language, because once we start getting into muscles and I say stuff to you like pronator teres pronates the elbow, if you don't know what that looks like, if you don't understand what that movement is, then you're just memorizing terms. You're saying, okay, fine, pronator teres pronates the elbow, brachialis flexes the elbow, deltoid abducts the shoulder, and we're just memorizing a bunch of terms without seeing them. You need to see what these movements are. So in the entire muscle unit, it's a very active unit in the sense that you really should be moving these joints around as you're learning the muscles. Don't just sit and stare at words on a page. And so this chart, you should be, honestly, as you go through, you should be able to reproduce this chart really by the end of this lecture. So when you're done with this lecture, what I would do is I would shut it down, take out a sheet of paper, and reproduce this chart. Then after you're done with that, look at this actual chart to see what you got wrong. then tear it up, and then do it all over again until these movements are very, very, very clear in your mind. And again, standing up and moving the shoulder, elbow, wrist, and fingers. That's how you need to study this. So assuming you've done that to a certain extent, I want you to think of muscles as a rubber band. So here I have a rubber band illustrated, and I'm just going to draw it out as this kind of image on PowerPoint. And so this right here is now your rubber band. So if we take that rubber band and we start to stretch it out, I'm going to grab this tip and this tip, like the north and south poles, so to speak, of the rubber band. I stretch it out even more, and I stretch it out even more. And then finally what we get is this stretched out version of the rubber band. Okay, so that is this rubber band, or this green rubber band. It's been stretched out here to here. And again, how have I done that? I've done that by grabbing onto this pole or this tip, and then this pole or this tip down below. Now from there, you understand which way does the rubber band want to retract? Which way does it want to spring back to regain its shape? And this is it, right? The arrows are pointing in. In no way would these arrows ever point, side to side. You know, if I were to just let go, then this end moves in the direction of this blue arrow, and then this end moves in the direction of this blue arrow. There is no other alternative. There's no way that this end is going to start moving out in this direction, right? It just can't happen the way this rubber band is set up. So the tension is generated here, and this is the way the rubber band wants to move. On the other hand, if I lay the rubber band out this way, and again, same thing, I'm going to grab this pole here to the left and this pole here to the right, and I'm going to begin to stretch that out. And when I stretch it out, this is what I see. And again, which way does the rubber band want to recoil? It wants to recoil in this direction, right? With this right side pulling in towards the center, this left side again pulling into the center. In no world will this end, if I were to just let go. If I were to, guys, stretch this thing out, if I were to let go, in no world would this go that way. In no world would this end up going up north, right, in the direction of my cursor here. It wouldn't do that. It has to move back this way. And if you doubt that, then go grab a rubber band and then see what happens. So same thing, if we position it this way and I were to stretch out the rubber band, then if I were to let go, which way does it move? Well, this should move in this way. And then this end over here should move in this way, right, towards the center. And that's exactly what we would predict to happen. So it is very, very helpful for us to think about muscles in this way. Now, it's not exactly a rubber band like recoil, but it's a good way to understand the direction of movement. So if we think of it this way, here is my muscle stretched out, and one end of the muscle attaches to bone A, or bony part A. Another end, the south pole of the muscle, attaches to bone B. Now again, which way does the rubber band want to move? By now we've established that it wants to move in these two directions. And so if I let the rubber band do its thing, so again, the muscle is attached to bone A over here, and the muscle attached to bone B over here. I see a little gap here, but ignore that. Assume these things are attached. So what can this muscle do? Let's take a step back now and talk about what does this muscle do? Well, the options are it can either move bone A towards bone B, or it can move bone B towards bone A. Again, it can move bone A towards bone B, or move bone B towards bone A, or both at the same time. Now, if we were to think then along these lines, let's say you have some other forces holding down bone A. Okay, so here's my rubber band stretched out, and I'm about to let it go, and I'm about to say, rubber band, do your thing. Deltoid, do your thing. Biceps brachii, do your thing. Triceps brachii, quadriceps, rectus abdominis, do your thing. Okay. If I were to imagine that these maroon or red arrows are holding down bone A, okay, so they're saying, I'm not going to let you move, but now rubber band, do your thing. What would you predict? Well, what you would predict then is that, well, in that situation, I think bone B would move towards bone A as this rubber band shortens. I don't have an illustration showing you the rubber band shortening, but you can imagine what that looks like is that bone B then will start to move towards, in the direction of these arrows, bone A, as that rubber band also ends up shortening. On the other hand, if I were to fix bone B, but what I mean by that is if I were to have forces holding bone B down, and I were to say, okay, rubber band, now do your thing, what would you predict? Well, you'd predict bone A then to move in the direction of bone B. All right. So you need to be very, very comfortable with this idea because, again, this is the way we're going to think of muscles. So here's a muscle. This is the biceps brachii muscle. And ignore these labels for now. We'll talk about those a little bit later, likely in another video. And so if you look at this muscle over here, what I'm saying to you is that we can actually think of that thing as a rubber band. And what is that rubber band attached to? It's attached to this bone. Like if you were to look at that, this goes all the way up and attaches to there. I see that my oval didn't quite extend that far, but hopefully you get the point here. It attaches to bone A up here, and it attaches to bone B down over here. Now, that you've covered bones, you should know that, well, this is the coracoid process of the scapula, and this is actually the radial tuberosity of the radius. So this is biceps brachii. So now if I were to say, okay, biceps brachii, I'm going to let go. You do your thing. You do whatever it is that you're designed to do. Here's the question now. What is the function of the biceps brachii? And your answer needs to be, it brings either bone A towards bone B, or it takes bone B towards bone A. Now, let's say that differently. What is the function of the biceps brachii? Well, the function of the biceps brachii is to bring the coracoid process toward the radial tuberosity, or to bring the radial tuberosity up toward the coracoid process. Now, keep in mind, it's not going to get all the way there. I'm saying toward, in that direction. I'm not saying that two bones are going to touch each other. In fact, that never happens. But it's going to move in that direction. So one more time, what is the function of biceps brachii? To take bone A and bring it towards bone B, or to bring bone B and bring it towards bone A. So what does that look like? Well, imagine this. If that bone B comes towards bone A, what's going to happen? This entire bone is going to come with it, right? This entire bone is going to come with it. And as that happens, if you can imagine that pivoting right here around the elbow, then what do we just see? Flexion of the elbow. We see flexion of the elbow. On the other hand, does the scapula ever come towards the forearm? Does that ever happen? And it actually does. So imagine, I don't have a picture for you here, but imagine you are hanging from a bar, right? You're in a pull-up position. So you've grabbed onto a bar and let your body weight hang from that, or like from a tree limb. And now you go to do a pull-up. As you do a pull-up, what ends up happening is that your shoulder blade is now coming up toward the forearm. But when that happens, again, the elbow is flexing. So here's the point. The point is that when you think of muscles, what you need to be able to do is with every muscle that I show you, or every muscle that you look at, visually, you got to look at a picture of these guys. Don't just use flashcards, look at a picture. You should be able to predict its function. So if we go to this muscle in the back, for example, here it attaches to, well, it looks like it attaches to the backside of the humerus. And here it stretches down and attaches to what looks like the olecranon. And so what does that muscle do? It either brings the back of the humerus toward the olecranon, or the olecranon toward the back of the humerus. And imagine that happening. Imagine we had this rubber band over here and you were just to let it go. Now, you don't have to think of the rubber band retracting entirely. Let's say it just retracts 20%. And when that rubber band retracts 20%, what movement are we going to see? That is going to pull right over here. It's going to pull right over here, and that will create extension of the elbow. So what we want to be able to do is we want to be able to understand muscle functions, look at pictures, and predict their functions. And if you do it that way, it is a little bit tedious, and that's how I'm going to progress through initially with the muscle videos. But if you can learn to think of it that way as, well, what does that muscle do? Bone A goes to bone B, or bone B goes to bone A, or both. And then name it. That's abduction of the shoulder. That's flexion of the elbow. That's dorsiflexion of the ankle. If you can do it that way, then it'll be a little bit more difficult than memorizing flashcards in the beginning. But down the road, it's going to pay off. I promise you it will pay off. Because at that point, it's the equivalent of a kid learning 2 plus 2 is 4 and memorizing that, and 4 plus 4 is 8. He can memorize addition, or he can try to understand how that actually works. And down the road, when he's doing 625 plus 819, then instead of being stuck saying, oh, I never memorized the answer to that problem, he's able to say, well, I know how to do addition. I know how to do addition of single-digit numbers, double-digit numbers, and I guess triple-digit numbers are not that far removed from that. And so then he can do any math in the world, or any addition in the world. Similarly here, if you think of muscles as attaching to point A to point B, then you'll be able to predict the function of any muscles. Now, most of the time, not most of the time, some of the time, you won't get it exactly right. Your prediction will be a little bit off because the way these muscles are shaped are sometimes a little bit less intuitive. But as a general theme, you'll have pretty good guesses. Okay, let me wrap up this video and then we'll continue on another one.